Welcome to the Informatica Cloud 201 On-Demand course. Module 4, Hierarchical Connectivity REST Web Services. After completing this module, you will be able to understand the types of web services supported in Informatica Cloud Platform. Focus on RESTful web services, use the REST connector, compare JSON and XML, and build a DSS that connects to OpenWeather via RESTful web services and returns data. First, let us understand what web services are. A web service is a collection of open protocols and standards used for exchanging data between applications or systems. It is a service that is available via standard web protocols such as HTTP, SOAP applications, or systems. Web services are a set of tools that can be used in a number of ways. The three common styles of use are XML over HTTP, SOAP, and REST. Web services use transport protocols for transporting messages between network applications. It includes protocols such as HTTP, SMTP, FTP. HTTP transport protocol is used to send data, used by World Wide Web, and is the most commonly used transport protocol. Now you need to understand what is a payload to understand the functioning of the web service. In a broad sense, payload is actually the content of the message that you are sending using the transport protocol. In most of the web services, the payload is an XML format. You can also find different types of XML messages. ATOM, ATOM, is an agreement of XML with certain tags in it. It is a standard way of describing the data. Other examples of payload XMLs are MIME or Multipurpose Internet Mail Extension, which is used for transport of multimedia information via synchronous Internet mail. Binary files, which can be base64 encoded, or text, which are used as payloads for FTP transfer. Another type of payload used is JSON, which is non-XML type payload. JSON stands for JavaScript Object Notation. It is a self-describing language like XML, which is newer, lightweight, and consumes less data to send, and hence it is faster. It is currently not supported in Informatica Power Center, which is one important reason to use Informatica Cloud. Now let us see why do we need web services. Take a look at these systems. These systems could be created by a different set of people who may or may not be there in the organization all the time. These people may have used various approaches to create these systems. These systems could be non- or semi-structured systems. Without web services, you will need to build point-to-point data integrations between all these systems. In such a type of setup, if something breaks or is needed to be fixed, you are not sure on what needs to be done. At the end, it may become a complex riddle because you don't know the technology that was used for setting these systems. So in such situations, web services functionality can be used. Web services are open standard, XML, SOAP, HTTP, etc. Web services are open standard based web applications that interact with other web applications for exchanging data. Web services can convert your existing applications into web applications. Web services allow structured data sets. Structured data sets are organized and lets you access everything in the same way. As per ZappThink, 70% of IT development budgets are spent on integrating different systems. Web services provide interfaces based on industry standards, using which you can access and integrate systems easily. Web services are use case based, as opposed to the point-to-point solutions. The more systems you have, the more you need to integrate them. Now let us discuss different types of web services available. There are three types: REST, SOAP, and XML over HTTP. Let us discuss each of these in detail. REST, also known as Representational State Transfer, or RESTing or RESTful web services. In the REST architectural style, data and functionality are considered resources and are accessed using Uniform Resource Identifiers or URIs, commonly known as URLs. In REST, in the query string of the URL, you type in command with data that you want to send to the web service and get back a response in XML or JSON format. These web services are simple and easy to test. SOAP stands for Simple Object Access Protocol. It's a standard protocol used for message exchange between web service and client in XML format. All SOAP web services require a WSDL or Web Services Description Language. It's an XML file that describes the technical details of how to implement a web service. SOAP web services are complicated and therefore require WSDL to describe them. These web services are too difficult to manage manually, and hence you use WSDL to generate code for them. SOAP web services are of two types. RPC encoded. This is procedural in nature, which means that it asks for the data by the name of the procedure and for certain data types. For example, give me account details of customer since this given date. Document style indicates that the SOAP body contains an XML document, which can be validated against a predefined XML schema document. An XML message is created that contains all the required information. You send the request and get the response in XML format. The third type of web services used is XML over HTTP. In this case, XML is posted over HTTP to access web service resources and return the response in XML. REST was first introduced by Roy Fielding in year 2000. REST is an acronym for Representational State Transfer. It is web standards-based architecture and uses HTTP protocol for data communication. It revolves around resources. Every component of a REST web service is a resource, and the resource can be accessed by a common interface using HTTP standard methods like GET, POST, PUT, or DELETE. Hence, if you need to access the resource, you send messages or requests to the server that contains the resource. Each message consists of an endpoint URL, type of operation to be performed, the request header, and request body. Now that we understand what is a web service, we will now discuss what are the different parameters of a RESTful web service request message. URL. Each resource in REST architecture is identified by its URI, commonly known as URL. Purpose of an URI or URL is to locate a resource on the server hosting the web service. We can pass parameters in the URL which can be used to process the request. Such parameters are called URL request parameter. Method or verb represents the HTTP operation that is to be performed, whether GET, POST, PUT, or DELETE. Header contains metadata for the HTTP request message as key value pairs. For example, client type, format supported by client, format of message body, cache settings, etc. In order to post a request, we may pass parameters in the header section of the request. Such parameters are called header request parameters. Body. It is the actual message content. In a RESTful service, the representation of resources sit in the body of a message. We may pass parameters through the body as well. Such parameters are called form request parameters. This example shows a REST request message in XML format. The first line shows the HTTP method used in the request, which is GET, and the endpoint URL. The complete XML payload message starts from the next line. This message is processed to retrieve all the bookmarks and tags of a given user. Let us now discuss the details of a REST web service response. The REST web service response is an HTTP response containing two parts. Response header. This contains metadata for the HTTP response message as key value pairs. For example, content length, type, response date, server type, etc. Response body. This is the actual content of the response message. This message can be in XML or JSON format, JSON being the most common type of format. Let us now discuss what services or protocol fit inside a web service. XML or JSON in the payload. XML most common for SOAP. JSON used only for REST web services. Reason that XML and JSON are used as payload because the data is self-describing. You can thus send the whole payload to the target system and it would understand the request you're looking for. SOAP and REST. These are the message format or different representations of a web service. Transport protocol: HTTP, SMTP, POP3, IMAP, FTP, Telnet, Gopher. These are various standard protocols used for data exchange, out of which HTTP is most commonly used protocol used by the web services. When you need to read data from or write data to another endpoint in Informatica Cloud, you must first find out what kind of web service it is, what are its inputs and its outputs, and what components in Power Center will be used to convert the data into rows and columns. These questions will help you understand how to connect to other endpoints via the web service. Let us now consider the Twitter API example to demonstrate how using REST API we can send a request and receive response in JSON format. As you can see, the highlighted text represents the query string. The query string contains the input to the web service, which is used to process the data and return the response. In most of the cases, REST API returns response in JSON format. JSON is lightweight and transfers less information about the data being transferred over Internet. This provides better security to data transfer, and hence JSON is preferred over XML. Please note that the advantage of using Informatica Cloud is that it supports response in JSON format, which is not yet supported by Power Center. REST web services can return response in XML or JSON format. Let us discuss the pros and cons of a REST web service returning XML response. It is lightweight, easy to understand, and easy to test by humans. However, there are some cons to it as well. They are not flexible, and hence it is harder to generate code from a RESTful web service if the HTTP returns a response in XML format. Some example applications are LinkedIn, Twitter, Facebook, etc. Now that we have discussed the RESTful web service where the response is returned in XML, let us try to understand the basic difference between response returned in XML format versus response returned in JSON format. JSON is extremely lightweight. XML, on the contrary, is extremely verbose. It is used commonly in JavaScript-enabled web clients, while XML is better suited for Adobe Flash, Oracle ADF, Microsoft InfoPath, or open-source solutions such as NetBeans. JSON deals well with atomic values or list of hashes of atomic values. On the other hand, XML deals extremely well with complex unstructured data. JSON is better for schema-less and entity-free data, while XML is better suited for namespaced, well-formed, mixed-content documents. Let us now discuss media, request, and authentication types supported by the REST connector. REST connector supports application XML, application JSON, text WML, text plain, and application XWWW form URL encoded media types. Media types treat the body of an HTTP request or response as a part of an application-specific interaction. So if the media type is application XML, the header simply tells the client that it should expect some XML formatted text. Similarly, if the media type is application JSON, the header simply tells the client that it should expect some JSON formatted text. Of these, application XML and application JSON are widely used. REST supports 4 request types. They are GET request type. These requests are used only to read data and not to change it. Therefore, when GET is used this way, it is considered safe. That is, they can be called without risk of data modification. Additionally, GET is idempotent, which means that making multiple identical requests end up having the same result as a single request. The next type is post, which most often utilized to create new resources. In particular, it is used to create subordinate resources, that is, subordinate to some other resource. Put is another type of request, which is most often utilized for update capabilities. Put puts a file or a resource at a specific URI, and exactly at that URI. If there's already a file or resource at that URI, put replaces that file or resource. If there's no file or resource there, put creates one. The last request type supported by REST connector is delete, which is used to delete a resource identified by a URI. REST supports the following authentication types. No auth, that is, no username and password required. Basic auth, it is the HTTP basic authentication, which is based on a username and password. Digest auth, authenticates a user based on a username and a password. However, the authentication is performed by transmitting the password in an encrypted form, which is more secure than the simple base64 encoding used by basic authentication. OAuth. OAuth is an open standard for authorization, commonly used as a way of Internet users to log into third-party websites using their Google, Facebook, Microsoft, Twitter, One Network, etc., without exposing their passwords. To optimize the connector functionality effectively, you need to follow the given recommendations. In case you like to fetch data using a query string in the URL, you can fetch data based on a single parameter mentioned in the query string. For a list of parameters, you could use URL input parameters config file, form request parameters config file, and header request parameters config file. It is recommended to give the URL request parameter, form request parameter, and header request parameter should be such that it fetches maximum data from REST endpoint server. This allows the connector to analyze and store more metadata. Use JSON-based response, as it is proven more stable when the same endpoint supports both XML and JSON-based responses. You should use the sample resource XML or JSON file field to manually control the metadata. Any manual change in the file would change the list of tables or records or the fields once you click Refresh Fields. Let us discuss the best practices for using REST connector. Ensure you have the correct authentication. You could use your browser to test your authentication is correct. If there is a choice between XML or JSON, choose JSON for obvious reasons we have discussed previously. To manually control metadata, fill in the sample response XML or JSON file field in connection parameter. Upon receiving the response, you can download raw response data from REST Webservice into a separate folder. The raw data will help you understand whether the response is minified or not. A leading media group needs to report to a large group of subscribers daily. The information needs to be as authentic and as real-time as possible. In providing customers with the various latest updates according to their preferences, the company faced some major challenges. Amongst the various domains of media content such as sports, politics, electronic gadgets, etc., there were problems with the timely, clean, and authentic updates being fetched from different sources. The average time needed to meet all the requirements was sometimes as large as 24 hours, which decreased the credibility of the updates. So to establish the subscribers' trust and to enhance the user group experience, they needed an alternative to the present system. The organization used Informatica Cloud's REST connector as a solution for data collection and integration related to various media contents. The REST connector helped to integrate data from various REST API-based applications. These applications were both external and internal to their present application. This easy integration of on-premise and external data using the REST connector helped them updating and informing the subscribers with the latest updates of their choice at the earliest. Hence, each subscriber is now served with media reports from the area of the interest within few minutes with complete reliability from the source. This ultimately results in multifold expansion of the user groups. In this demo, we will see how to obtain OpenWeather API from Informatica Cloud using Informatica Cloud REST connector. First, we will create a REST connection. Log into the Informatica Cloud org and select Administrator Services. Navigate to the Connections page under Administrator Service in ICS and click the New Connection button to create a new connection. Enter the connection name as OpenWeather REST version 2, and from the Type drop-down, select REST version 2 Informatica Cloud. From the Runtime Environment drop-down, select the Runtime Environment from the available options. From the Authentication drop-down menu, select REST version 2. Ensure that None is selected in the Authentication Type drop-down menu. Enter the path of the Swagger JSON file stored on the Secure Agent file system. From the Proxy Type drop-down menu, select Platform Proxy and enter host:/proxy in the Proxy Configuration field. As the connection is successful, click Save to save the connection. The REST connection is now created. Next, we will create a synchronization task which uses this REST connection to fetch requested data from the API and write it to the specified target. Log into Informatica Cloud org and select Data Integration Services. Select New from the navigation pane and select Mappings. Select the mapping option and click Create. In the mapping properties, enter the name of the mapping as mREST GetWeather by City. Click the source transformation available on the canvas. In the source properties pane, in the name field, enter src. Under the Source tab, from the Connection drop-down menu, select the REST connection, and in the Operation field, click Select. From the Select Operation window, select Get and click OK. Expand Request Options and click Configure. Copy all text from the request message template and paste it inside the request message editor. Replace the app ID and queue with the API key and city name. Click the Validate icon to validate the request string and click OK. Under Field Mapping, click the drop-down button to expand the Get Output route and select Map All Descendants. Link the source to the target. In the Select Output group pop-up window, select Route and click OK. Rename the new target as TGT in the General tab and click the Target tab. Select the flat file connection and for the target type, select Single Object. To select the object, click the Select button. In the pop-up window, select Create New at Runtime and provide the file name as weatherbycity.csv and click OK. Click Validate to validate the mapping. As the mapping is valid, save the mapping. Click Save and the mapping status is displayed. To run the mapping, click Run. Select the runtime environment and click Run. Click My Jobs in the navigation pane to see that the task has run successfully. In the My Jobs window, we can see that the task ran successfully, and there is 1 success row and 0 error rows. This concludes the demo on hierarchical connectivity. You're now ready to practice using the REST API. In this lab, you will create a REST connection using REST connector, create a DSS task to consume RESTful OpenWeather service, get JSON message and write that to a flat file. In this module, we discussed types of web services supported in Informatica Cloud Platform. Focus on RESTful web services, use the REST connector, compare JSON and XML, and build a DSS that connects to OpenWeather via RESTful web services and returns the data.